Today, I thought it would be nice to see some useful yet simple scripts using Node.js. So the idea is the following. We want to create a small database of stuff that we gather. This is not going to be a real database, like a relational database. It's going to be like a JSON file. We're going to build a small JSON database, meaning this is going to be a very simple and easy to maintain and edit text file in JSON format. And then we'll put some information that's relevant to us. This can be anything from like technical notes, tasks that we want to do. This can hold anything, like any kind of like information. And the script that we are going to create is going to be used to search through that database. So basically what we want is have an easy way to create and maintain a kind of like JSON database, like a simple file with some sections and a simple JSON structure. I'm going to create this file right away. So data.json. It's going to be an array of entries of objects that we will put in here. And then we're going to have a script with just a few lines of code. And we're going to use this script to open up our terminal and then search through this database for something that we want to like quickly find out. And we're going to use two algorithms to search through this database. Fuzzy searching algorithm, which is basically kind of like, let's say, a more advanced string matching algorithm. So instead of just searching for a very specific keyword, so instead of like searching JavaScript exactly in, let's say the target is JavaScript, these fuzzy searching algorithms, so how to build X in JavaScript. So let's say in our database, we have an entry like this, and we type JavaScript, and then we find, like, according to the keyword, if JavaScript is found inside the database. So this is like the search, and this is the database. This simple string matching algorithm, this is kind of like a very simple, let's say, comparison that we can do in JavaScript, in plain JavaScript. If this string is found in this string, then we have a match, okay? So this is the simplest, but what's cool is that with fuzzy searching algorithm, we can do something like, I don't know, maybe if we make a typo, we can still find the result, because JavaScript, or even if we omit another one, you can see that this string is very similar to this string. So these kind of like more advanced algorithms like fuzzy searching are much more advanced, because if we mistype something, or even if we, I don't know, for some reason we type this, we break the words, or maybe even we type them differently, or maybe we just type Java. Fuzzy searching is smart enough, allows us to find relevant search strings or relevant data in our database, and also give us the opportunity to see how close or how far these matches are. So for example, Java would be relatively far, because it's just like we just found 4 characters that match this string, whereas let's say Java, something like this, it's a little bit closer because it contains more characters. So fuzzy searching is one step ahead of like the simple string-to-string comparison. So you will see that it's far more powerful. And then we can also do searches like how to, or let's say, can I build in JavaScript? So I can search for something like this and still get a relevant search result. So even if we type something that's not strictly or exactly like the entry in the database, we can still use fuzzy search to find a relevant match. So you can see this query is very close, like, or similar to this one. And this is how fuzzy searching helps us find relevant matches. And then we are going to use an even more advanced library and a more advanced algorithm. So we're going to be using a vector search algorithm, even more advanced, but has a higher precision. So not only can we search in like very different ways. For example, I can search in a way that's looks almost completely different. Can I create X in JS? So I can write a query in a completely different way than I would usually find in the database and still get a result. So by using this more advanced vector search algorithm, I'm going to have even more precise results, and I have the freedom to express my questions or my searches in a free form. So we're going to see how we can build a script that uses these two different algorithms to search through a simple database and give us back some results that we can use. Our database is this data.json. I have this data.json. I will add another file called search.js. I'm going to open it up in here. Now, the next thing I'm going to do is, since I'm going to be using some libraries, I'm going to be installing some JavaScript libraries from npm. So remember, we are going to download and install npm packages for these two algorithms. So for the fuzzy search algorithm, I'm going to go to npm.js.com, the JavaScript repository, and I'm going to search for Fuse.js. So Fuse.js, it's a really nice, it shows this is a lightweight fuzzy search. So this is a fuzzy search algorithm library. You can use it in the browser. You can use it in Node.js. So it's a relatively lightweight library. You can see it has like almost more than 5 million weekly downloads. So it's pretty, I would say, trustworthy. You can also go to the GitHub repository to check this out. I'm going to copy this npm. And for Fuse.js, we are going to need to run this command. So npm I or npm install Fuse.js to download and install this library on our system. And what npm is going to do, remember, Node.js comes bundled with npm. So if you already installed Node.js and you have Node.js installed, you get npm for free. So you get also npm install. And in order to install this package, so basically when you type npm install, what npm is going to do is going to go to npm.js, look for this Fuse.js entry. It's going to get an answer from npm. It says, yes, I have this package. And then npm will try to download this and install this on your local folder. The place where npm installs these modules is called in a folder called Node modules. So npm is going to find this online repository. It's going to pick up Fuse.js, which is basically a bunch of JavaScript files most of the times, and it's going to create a Node module folder. So it's going to do this automatically. Inside this Node modules, it's going to create another folder called Fuse.js, probably. We'll say so, something like Fuse.js, and then it's going to download a bunch of files that are going to be used to power this library. So this is what this npm install does. I'm going to remove this Node modules folder because we're going to let npm do this job for us. And then once you have this Node modules folder with the library, you can use it, and then you can import this library, this npm module, in your JS code using two ways, which we are going to take a look. And then you have full access to this library. Now, before starting and doing this npm install Fuse.js, I'm going to run another command that is useful and nice to do and run before you start any Node.js project, and these days also any JavaScript project. So there is a command called npm init, which you are going to use to initialize a new npm project. So basically, when you start a new JavaScript project, you want to initialize this project as a JavaScript project, and that's what the npm init command is going to do. So we're going to start with npm init to initialize a new JS project. And npm init is going to do two things: ask a bunch of questions about the project. When I run this command, there's going to be a dialogue between me and this npm init command. It's going to start asking some questions, like, what is this package name that you're going to be building? So npm thinks in terms of packages. So maybe we give it a name like search engine, or you can give it any name you like, and you can always change this name. And then it's going to ask you about the version. So I'm going to give it a beta version, local. Then you give it a description, and you will see that npm init starts asking these questions. When we finish going through this dialogue and finish up with all the question. npm init will create a package.json file. So you will see by the end of this first step, we're going to get a package.json file created automatically by npm init. And this is our project's recipe. Whenever you want to share this project, this recipe with other people, the only thing that you need to share is the source code and this recipe file. And the recipe file contains the ingredients. In our case, our ingredients are the two libraries, Fuse.js and the vector search library. We're going to take a look at this in a bit. Maybe if we weren't using any external ingredients and external JavaScript code, we wouldn't need the package.json, like a recipe file, but most of the times, and in this case, we need this package.json. So we can let other people know about our ingredients, about the ingredients that this recipe uses. Because just like in real life, when you want to share your project or when you want to share your recipe with other people, you just hand them the recipe, you don't hand them the ingredients, right? So that's the package.json. So npm init is going to create this recipe file. So let me go through the rest of the questions. I finished with the description. The entry point is basically let's say the main file. It already saw that we have a search.js file. So I'm going to hit enter. Test command is about testing the app. I'm going to skip it for now. The Git repository is the address of the Git repository. So if you have a remote Git repository on Bitbucket, on GitLab, on GitHub, somewhere, you just put the address in here, like https github.com, and then search engine, something like this. In my case, I'm not going to do this right now. Enter keywords. These are some keywords that describe this package, this app. So I don't know, JavaScript and search and I don't know, JSON and database. The author type something, the license type. Now this is what I was talking about. This is the import. So we have two types. We have two ways of importing and exporting JavaScript code in Node.js. We have the common JS and we have the module. Okay, so unfortunately in Node.js, we have two ways of picking up a way of importing and exporting external files. The kind of like old way is the common JS, and the, let's say, more modern way, I would say better way to use is module. We're going to start with common JS, and then we're going to switch to module to see kind of like roughly the difference. But in this case, it gives you the opportunity to pick one or the other. So in here, you press enter and pick common JS, or maybe you want to switch to module. Suggested, let's say, recommended way. I will pick enter, and then it gives you this confirmation window, and it says this is what I'm going to be putting in the package.json file. So you can see this is JSON file. This is the recipe. At this point, you'll see that there will be no ingredients. We'll talk a little bit about this, but basically this is the recipes or the project, let's say, information, like the name, the version, the description, the main file that the users or other developers will have to run in order to run this application. Because if you have like 20,000 JavaScript files, who knows which one is going to initialize the app. So in here, you type usually the file that it's going to start the application. We'll see about the scripts later on. The keywords, as you can see, this is an array of the keywords that I added earlier, the author, the license, and so forth. If you're okay, you type yes or you press enter, and now you'll get your recipe file. And everything that we saw in the terminal is now inside this JSON file. So this is your recipe information. You can change every single bit of this recipe. So you can go here and say search JSON database engine. You can change the version or whatever. So all these things can be, say, fuzzy. You can change this at any point in time. And you can also change the type from, you will see if I remove this one and I type, VS Code automatically gives me the two available options for this property. In here, I only have two options, common JS or module. Press tab. In the other sections, I can freely add whatever I like. In the name, for example, there's no predefined options. I can type anything I want for a name. So you have your recipe, and you will see that in a moment, the ingredients, the external ingredients that we're going to use, they are going to be placed in a separate section called dependencies. So when you start adding ingredients or so-called dependencies, they're going to be shown in here. So when we add this Fuse.js library, vector searching library, they're going to be installed and shown up in here. So we'll come back to this this recipe file. And now let's go to the scripts section. In the package.json, we have this scripts, which by default has this test entry. So this section is all about providing certain keywords in here on the left side. Let me add another one. Let me add 2 entries, whatever. So in here, basically, you add some keywords here on the left, like test, start, whatever. These can be, most of the times, these are single words. On the left side, you write some kind of a command line command, something that will be executed on the terminal. So let me change this to, let's say, ls. And what this does is it allows you to open up your terminal, type npm run, and use any of these words. So all these entries are now available using the npm run command. I can type npm run test, I can type npm start, npm run list, and anything else you'll provide in here. And when you run these commands, these terminal commands will be executed. So npm run test will find this script entry, test, and execute this command. So if I run this, we will see error test not specified. So this is just echo. It's just a simple terminal command that echoes, like displays something in the terminal and then exits. So let me type something like test not ready yet. So now npm run test. Let me run the npm run start. I get to see kind of like the name of the package, the version, and the command that I run. So this is kind of like debugging information. Then npm run list. This will run the ls command, the terminal ls command, which just lists the file on the terminal. So if I run any of these commands on the terminal, you'll see, the results here. This is our basic, like very simple, like plain terminal commands. This is not something special. Okay, just the directory contents. And the script just allows us to create a shortcut that we can use through npm run list. So the same result with the terminal command ls, just that we have them available as a set of scripts that are, let's say, for some reason useful for our application. So if I found out that there's a command that's kind of like relevant to my project, maybe I need a command to create this file, this database, if it doesn't exist. So let me remove the data.json. And I say to people that are going to be using my app that you need the data.json for this script, otherwise it will not work. So I create a script called create.db, which is going to do exactly like that. Create a file data.json. So anyone that wants to run my app, they will first have to create a data.json file if it doesn't already exist. So you can either run stats.json and find the file here, or let me delete the file. Or you can now run this npm create db. And you see the file here. So this is kind of like a list of commands that are useful or maybe necessary or required for the users of this recipe in order to do something like start the application. So maybe we can say the start is going to be Node search.js. And create.db is all about like creating a new data.json, and that's like 2 scripts that are required. So script is like a special place for keeping these scripts. Package.json scripts run terminal commands that are required or helpful for the app. And you see that the default kind of like entry that is created, it's the test, okay? So the only command npm init creates is the test. Now, let me open up the data.json. So for this demo, I'm going to create a database of useful questions that are related to web development, like questions like how do I center a div, how do I do this in JavaScript, how do I do this in CSS. It's kind of like an FAQ. And then we're going to be asking a question like how can I center an HTML element. And the search engine is going to be searching through this database, finding the relevant answers and giving back the most relevant answers. So the structure is going to be a series of objects. So our database is going to be a series of objects that have a title. So this is sort of like a question. We're going to be adding a set of tags, something that describes this question, this entry. This is a CSS language related question. This is related to like the layout. So centering something, positioning something is all about the layout. And maybe the word center is also crucial. You'll see how we can use the tags to give back a more relevant search result. So the title, sometimes the title is enough, but sometimes you need some extra information to search. So the tags really play a crucial role in this. We have the content, which is basically like the answer, and a created at is just an entry about when this entry was created. So this is going to be our database. Same structure for every question and answer entry. And I'm going to be copying and pasting the rest of this small database. There's going to be 10 entries. Copy them here. So this is just a bunch of entries on how to center a div in CSS, how to get the last array element. So you can see title, the tags are relevant to JavaScript and array, how to get the current year in JavaScript, how to disable the submit button, and so forth. And this is our database, which means that you can use this structure to build any kind of database. You can build this to enter your own questions and answers, which are related to JavaScript, CSS, personal health, news. So this can be anything you like. So you're going to be using this structure and this application to build your own database and your own search engine. And then through the terminal, you'll be able to quickly search through your personal notes and entries. The way that it's going to work is that we have this database and we have the script. And basically what we want to do is we're going to be running something like node search. How do I make fonts bold in CSS? So you'll be running node, which is going to execute the search.js file, and then pressing space, you'll add the rest of your question. And what we want to get back is this answer, the expected. See something like this. This is our goal today. A simple script that searches through a database and we get the answer quickly. And this can be updated manually all the time. So you keep a list of relevant information, relevant to you, and then you'll have your own personal search engine, which is offline, really lightweight, and you can maintain it and copy it and share it with other people, which is really cool. Now, the first thing that we need is to take care of the query, the user input. So how can we grab this input from the Node script? We learn about the process.argv. So this is a special variable called process in Node.js. It's an object which contains a property called argv, which is basically containing all the user input. All this thing is included in this variable. And if I run this, you will see that every single word is in here as a full path. So node is not just node, it's the full path to the node command. On my system, node is found in user local bin node. Search.js is also a JavaScript file and I get the full path. So this is where search.js is found on my computer. For the rest of the words, I just find this array string entries. So if we want to get this whole thing as a string, what we need to do is disregard the first two entries of the array. This is an array, so we can get the first entry like this, the second entry like this, and so forth. So we want to get rid of the first two entries, which are these two guys. And then for the rest of the entries, grab all of them and put them in the string, like connected or concatenated with spaces. If I console log the first three elements of the array, you will see node, search, and how. Now, since process.argv is an array, I can slice the array and I can get only certain parts of the array. So if the array is like A, B, C, D, E, I get the index. So I get element at position 0, 1, 2, 4, and so forth. So this will give me the first element, A, this will give me the second element, B, this will give me the third, 2, and so forth. But if I want to get all the elements from upwards from 2 up to the end, 3 up to the end, 1 up to the end, or 0 up to the end, I can use the slice command. So the slice command allows me to start at a specific point, like 0, 1, 2, 3, 4, whatever, and then pick up all the rest of the elements. So if I want to start from 0 and get all the elements, I type 0 here, and I will basically get all the array. Let me comment this. If I want to start from element 1 onwards, I will type 1, and I will get all these entries. And if I want to start from the second onwards, so just get the keywords, I'm going to type 2. So now I get the array elements that only contain the question, the search query, right? But it's an array of strings. If I want to grab all the strings, these array elements, and concatenate them together, make a string out of them, I can use the .join, which is going to take all these entries and concatenate them together, join them together in a single string. If I type now, I'm going to get a string which combines by default all these entries with a comma. I don't want a comma, so I can pass in a custom separator. So instead of using the default comma separator, I'm going to be typing here space. So this is going to connect all this, join all this with a space. If I type here a dash or double dash, it's going to connect them with a double dash. If I type blah, 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 it's going to connect them with all these things. So that's kind of like an easy way to grab this search keyword from your input and then have a string. So I'm going to say query equals, and this is what we're going to be using as a search keyword for a database. So get this and do a fuzzy searching to find similar entries in our database titles. Okay, and if I run this, it should probably ignore this one, and find a relevant match like this. And we'll see how we can fine tune this search engine. So we have our query. Next thing is, of course, to use a library that is going to be searching through these entries and giving me back the relevant results. For this, I'm going to install this package, the Fuse.js. So I'm going to go here, grab the installation command. So I'm going to copy and I'm going to go here and type and paste this carefully. Now you can see it says it added one package and it audited. Audit means it also checks for vulnerabilities or for whether this package is okay, and there's no problem. It didn't find any vulnerability, so it's safe. And you can see here that the npm is now, I've downloaded the package from npm. It created automatically a node_modules here. This folder wasn't here before, so npm install automatically created it. And inside here, it created another folder called Fuse.js, which contains all the files related to this library. So now we have this library available to us, and we can use it by saying something like fuse equals require Fuse.js. So when you install a dependency, in this case Fuse.js, remember we used npm install Fuse.js. That's why we can now require, we can import this. So this is like the common JS way of importing stuff in Node.js. So we use require, which is a function, then the name of the library. So you just copy the library name and place it in here. And what you'll get back is some kind of like a variable, a function, an object. It depends on the library that we're going to be using in our script. So you have to go to the documentation. They do not provide a link, unfortunately, to the documentation. So I'm going to the GitHub repository site where they probably, hopefully have more information. They say that the documentation can be found in here. So usually you have kind of like an installation quick start section. So they instruct how to install this and then how to use this. And you can see here like the two types of importing the module. So we have the common JS. I'm going to copy this from the documentation. So this is the common JS. And if you switch to the ES6 or module syntax, you want to use this one. So if the type is common JS, you'll use this one, and you'll use this one if the type is module. For now, I'm going to stick with common JS. And then the rest of the code, it's basically the same. Then they have some instruction on how to run this in the browser. And then probably you want to go to some like the quick start section or maybe the examples. And they have some simple examples in here. So let's check this simple example. I'm going to go straight to something that's closer to our database, which is an array of objects. So I'm going to grab this and I'm going to say const DB. So this is going to be our database. For now, we're going to switch it to this one. So pretty much similar, right? We have title, author, tags, slightly different, but it's still an array of object entries. And then they have the JavaScript. And this is interesting. So first, let's study the code. And when we run this code, here it says that we are expected to see this output. If we search for this string, it's going to search through this small database, and it's going to come up with this entry. This is the search result. So title, author, tags. And why did it pick this one? Because if you check the string, the keyword, the only entry that contains these 4 characters is this guy here. And these 4 characters are contained specifically in here, in the tags. So you can see how powerful this fuzzy search is. Not only checks for a specific string, it also searches for like specific part of a string. This is included in here, so it gives us back a result. And it also searches in the selected specific areas in the data. So these are the keys. It says when I search for something, when I search for these characters, search in the author and see whether these 4 characters are found in here, or search in the tags. So in here, you can decide, you can select where exactly to search. You can see that in here, we are not searching in the title. We don't have title in here. So if we were to search for, let's say, old in here, we would probably get no results because old is not found on either of these tags or either of these authors. If we wanted to include the title as a search area, we would have to type. So let's run this and see the results. And you can see the results that apart from the one or multiple results that we'll get, sometimes we get more than one result, we get a reference index entry, which basically says this item that I got back is found in index 0 of the database. So this is index 0, this is index 1. And we also get a score, like how close is this match. You can see the score here is relatively small. It's like 3%. It says I found a result, but the, let's say, relevance or matching score is very low. And that makes sense because it only found like 4 characters as part of this word. If you get a full result, if you type for old and you get a full word, you will see that the score will be much larger because searching for a word and find the whole word is a better result. Let's see if I can run this. Let me close this one. Let's see. Search. Okay, I get list is not defined. Okay, so list, the error is here in search line 30. So I go to the search.js file, line 30, which is here, and it pinpoints the error point. So it says list here is not defined. And that makes sense because I have no list anywhere. So I have to provide this. My database is called list. I provide this to this initialization, and then I start searching. Okay, so I initialize this, let's say, search database by providing the input, my database, some options, where to search and whether to include the score, and hopefully we'll get a result here, which I'm going to console log. And I do get the item, the reference index, and the score. Let me try to check for these characters. So I now get this entry. The reference index is 1. That's the second entry in the array. And the score is a little bit higher. Another thing that this library gives us is the ability to configure the search algorithm. You have to read through this configuration and see that there's a bunch of ways that you can extend or you can configure or you can customize how well the search algorithm works and how you can fine-tune it. It has the weights. It lets you provide a weight to the certain keys. Like if you believe the title is far more important in the search algorithm than the tags, you give it like a higher weight. And then you also have other options like whether you want to search for case sensitive, like uppercase or lowercase, and that's the threshold. So the threshold is kind of like the limit or the how strict the search algorithm you want to be. The threshold by default is set to 0.6. So it's kind of like roughly 60%. So the threshold, it says if the threshold is set to 0, it requires a perfect match. So the threshold 0 means it has to find, let's say, exactly the same string. So it's very, very strict, very precise. So it's maybe not very useful. And as you push the threshold upwards, finds a result even if there's not a perfect match, right? If there's a part of the result, if there's like a small word and so forth. So you want to kind of tweak this value. Certainly, I would say not 0. It's far too precise, and maybe not go all the way up to 1, which is kind of like 100%. And as it states here, it will match anything. So it's certainly not useful. So you'll play around with values like 4, 0.4, 0.6, 0.65, and so forth. And there's still more options. That's the way that we can pass the threshold here. So 0.0 should be, let me try this one and see how it. Okay, so you can see this is very strict, like 4 characters will not work because it's a strict match. You need to find a strict match. Like you need to find like the no. That's like the lock. Let's say let's work with a lock. Still the same. So even though lock is found inside the title, because the threshold is too low, it needs to find the perfect match. So I think the only way this can work is if I put all the string here. Then this will work and will give me an almost like 90%, 92% like score. So this is very strict. So it won't work with the part of the keyword. And now in here, you want to play around with a few searches and a few threshold values. 0 is definitely not going to cut it. Let's type 40%. You can see this gives us something that we want. And then you play around and you, I don't know, find something that works for you. And I think also this one will not work because probably this will give me everything. This is kind of like too fuzzy. Even though the lock is not found in here anywhere, just gives you this result, and it's also gives you like 84%, so which is crazy. So that's not, these are two edge cases, values that you don't want to. Maybe start with 50% and play around like others, lower or higher value to give you these results. We have our search engine, which means that we now need to get the query from the terminal. So how to stop, let's say, a form submission. So I went to search through my database now and find, let's say, this entry. I'm going to switch from this dummy data, which I copied and pasted from the documentation, which is a good way to start. And instead of using this, I'm going to be using this data JSON. And instead of searching for log, I'm going to be using the query, okay, the thing that the user passes. So how do I read this data? So basically, I will use an Node.js package called fs, short for file system. So I'm going to be using this command, which is going to import a special built-in Node module. I don't need to npm install anything, okay? This is built in Node, no npm install required. It gives me a special module called fs, short for file system, which allows me to read and write to the file system, to my computer, which is really powerful, but also pretty, risky. So you have to be careful because you can not only read files, but you can also update and delete files. I'm going to use this, say fs read file sync, which is going to be using a synchronous command to read the data JSON file. And I'm going to pass a second option. I'm going to provide the text encoding. So UTF-8 is kind of like the normal way of encoding text data. This means that read this file, treat all text as this special text encoding. So this is a way that computers represent text. And this FS module is going to be using this command to read synchronously this file, encoding this, and then using it in the search. So instead of just supplying a hard-coded array, I'm going to be reading this JSON array and importing it in here. But since this is going to be a text file, so if I type list, you will see that I'm going to get just the text contents of this file and some errors. We'll see why. Okay, I made a mistake here. It's not Node.js, it's Node.fs. FS module is part of Node. Okay, and what you see here is the results of this text file, the contents, right? So everything that it found in this file is now available as a string variable in Node. So this guy, this is just one line, can read any file on your system and then supply to you as a string. But because this Fuse library works with structured data, not strings, but objects and arrays, we have to convert this into a JSON object. So I'm going to name this text, and I'm going to convert this into a JSON by first parsing it with a JSON library. So this is another built-in JavaScript command that accepts a JSON string. So this is a JSON string. It's a string, but it's also structured as a JSON with these curly brackets and these property keys and the double quotes and so on. And then we're able to parse it and pass it as a variable to Fuse, which really requires an array of objects. That's why it's breaking up here. If you pass in a string, it's going to say something like, I couldn't use for each, which is used for an array. I didn't get an array. So now hopefully we'll get some kind of results. Let me just comment this out. So you can see if I search for how to stop a form submission, I get no entries, even though I have this kind of like thing. So now you need to fine tune your search engine. So how can we get this result? One thing you can do is you can like make your threshold go a little bit up, make it a little bit less strict, So if I switch to, let's say 55%, let's see whether I get a result. I get way too much. So I get my result now, but I also get another one, which is similar, right? Submit a button. This is 70%, and this is like 8%, which is cool. So we found kind of like a sweet spot, at least for this query. So 50% is pretty strict. It gives me 0 results. And if I go to 55%, it gives me like 2 results that contain the words like form and submit. And I think they're both relevant, right? According to this question. So you keep on fine tuning by doing some other searches, like let's search for Node, search, make font bold CSS. Let's see what we get now. So I get this one, which is cool, with 73%. And now I can get the content and the answers. I can go in here in the result, and I can say, let's say, pick the first result of the array, give me the score, and then also give me the item and the content. So just the answer. Pick the score to have an idea about how relevant the result is. So if the score is low, like 20%, it's probably not very useful. And then just get the item.content. There's an object inside this object. I have to say item.content. And we have our score and the answer. Now, if I go back to the how to stop a forced submission, I get this one, which is nice, right? Like you get answer, and then in here, like you get the score, which you can like multiply by 100. And then you can use mathfloor to remove some of the decimals, and then add the percentage sign. You get this one, you multiply by 100. So with this will become something like this. Then we'll take this one and we'll use mathfloor to like remove the decimals, and then we add like the percentage, and we get something that's more user-friendly. So instead of a big decimal, we get like 73%. Now we'll get this one and this one. No, the CSS. Yeah, it's a nice search engine. So you can really put your own stuff in here and have things brought to you. And we can go a step further and like iterate through the results, because remember, the result is an array. This is like for the first print or display first result. But what if we have like 2 or more results? We want to say for const result. I will change this to results because it's an array of results. So now I'm going to iterate through results and display all of them. Now I'm going to iterate. We get an array, we iterate, and for every entry, for every result, we get this variable, which contains, of course, the result object, which contains the score and the item. And I'm going to get something like a little bit more. So I get 1 result here, but 2 results in here with some score. For some reason, I get the results without a specific sorting order. This has a low score, it's at the top, this one. And I think if I had the third result, which was like 50%, it would be at the bottom. This is just an arbitrary sorting order. You can go one step further and sort results by score. Like high score probably at the beginning, and you'll get something like it's a little bit more nice for you. Let's sum up. We have our database, and we have like just a few lines of code. You can see it all fits in like almost like 20, 30 lines, which is pretty cool. And you've just built your first local offline text-based search engine. Basically, this is it. If I remove the comments, you'll see it's like really, really cool that we get our own personal search engine for just like 16 lines of code, right? And you can open up your terminal any point in time, write this script and search for something that's really useful. You can build your own database of frequently asked questions, so things you like to remember. How did I go about converting a set into an array? You can just add a new entry. How to convert an array into a set, and then the content is going to be new array. So if you don't remember how we converted an array into a set, you use this one, and then you have like the how to convert a set into an array, and we got something like this. You put the tags, array, I would say set or sets, and then JavaScript. And now, if some time passes and you don't remember how we used to like use some syntax to convert between an array and a set, you can just go to your search engine and say node search how to convert array to set. Let's see what we come up with. We have this one, which is 62%. This one is still here, and we get some results that are really have a higher score, unfortunately, and are not relevant. So we'll have to work our way through fine-tuning and find maybe some tricks. This is up to you. This is kind of like the manual tweaking, like maybe add even more tags or maybe add another property that you want to include in here, like description, something that's related to the search query, and it's going to help the search engine pick the better answer. And what's really useful in here, in these cases, like in search cases where you get these mixed results, you get some results that you want and some other irrelevant results. This is where the weights really should be taken into consideration and used. So if you remember here, we had these weights, and you can say like give a little bit more weight to like the author and a little bit less weight to the title. If you see that the title mixes things up, then you pick another property like the tags or maybe the description or something else and give it a higher weight. If, let's say, one property has a higher weight and it contains something that will help the algorithm pick this solution, pick this answer, you give it a weight and you say, pay more attention to the author or pay more attention to the tags instead of just using like here. So now I should be seeing you can see now I get like a higher score here. And this is the fuzzy search algorithm. I'm going to close with an even more advanced algorithm. So I'm just going to be installing a new library and pasting some code, quickly go through the code, and I'm just going to leave it for you to like read the code, study the code, experiment. I'm going to be using a library which uses a far more advanced way of searching through strings. So I'm going to be copying some code in here and then explain like what it's like doing. So let me just run this and then I'll walk you through some of the code to see what's happening. So now we're switching to a different library. It's called transformers. I'm going to go to npm, find this Zenova transformers. And it's going to be using a far more like advanced and let's say smart algorithm to search through the text, not as lightweight as the fuzzy search algorithm, but gives us some really good results. I'm going to be using this library. I'm going to copy the installation commands for this one. So before testing this, I need to type npm I or npm install at Zenova/transformers and install another library called Zenova transformers. Now, first, let's try this and we'll see. Let's try the same result. Now, the first time you run the script, it's going to need to download some packages, some extra stuff, and it's going to take a few seconds. But subsequently, when you run the command again, it will be much faster. So now if I run this script, it will tell me that it cannot use an import statement, as you can see here, because I'm using the common.js module. Remember, this is the module type of import. We have type common.js. So if I want to use this import, like the different way of importing in Node.js, I will have to go here and type module. So for these guys, I need type equals module. Or I can switch to the require. I can keep the common.js and I can say const fs equals require fs, or the more formal is to put the note here to describe that this is a built-in module. If you want to use the common.js, you just use this syntax, and in your package.json, you say type equals common.js, and then probably const pipeline equals require in the library. So that's kind of like basically the difference between the. So this is like the type module. This is like, as you can see, it's a different syntax. Type equals common.js. I will switch to the type module for now to see like a different setup. Keep in mind that this script uses type module and this one uses the common JS. So you cannot run both scripts with one type. You have to either convert both of them into module or common JS, and you can have just one type in here. When you switch from one script to another, make sure to change the type here. So let's run this. Remember, the first time it's going to take a few seconds to download some kind of like extra things. Now it's not doing a really good. Let's see. Okay, so for this one, we have kind of like a score here. So I'm going to lower the score and I'm going to go through the code. Okay, so we have a result. Let me just comment this one. So let's see what we get first. So when I search for how to convert array to set, I get a bunch of results. So the first thing that's different in this using this library is that you get a far larger number of results, okay? And you'll get a score, which you can see it's roughly around 50%, like 53% for this one and this one. And you get other results, but they are far lower in the score. You get like 26% for this one. So you'll get a bunch of results. And in this case, I think you'll get all the results, like everything that's found in the database with just a score. And so it will basically sort your database based on some score. And you can see that some of these entries have a very, very, very low score, like which is almost irrelevant, and some other ones which will be even lower. This is why you want to filter the results based on some score. And here I say, okay, we get all this list, so filter the ones that are higher than 50%. So that's why we'll get like the first two entries. And once again, you tweak this value. So you play around with 51%, 55 or whatever, and you'll get just these two results, right? And then this is an array, so you like iterate. Item, title, and let's see the content, and let's see the score. We have to put the math floor percentage stuff here. It's okay for now. And we get like the results. For this one, you'll have to experiment. You'll see that it's far more precise and it does a better job in picking up relevant information based on the title. This is like the search algorithm. It works on the title. So it works on one part of the data set. It just picks up every title. It converts these titles, these strings into vectors, so basically numbers in a special way. So it uses a very advanced algorithm to turn text into numbers, and then it processes and compares them like vectors as these special numbers. But it works only on the title. So if you want to go one step further and include like the content or the description or the tags, you have to find a way here to like include this. For now, I would say just leave this to the title. So this algorithm picks all the titles and then it goes through some like advanced mathematical like comparison algorithms. So this is kind of like the magic box, okay? And this is like the black box magic. It works with certain like smart math. And what you get back is results that are far more like relevant to queries. So you'll see that you'll be able to run queries very, very different from what you see in the title. Let me try some things like you don't have to include strings that are exactly matching these strings. For this one, in the fuzzy search algorithm, you have to include something like disable or submit or form. You have to include, but with the vector search algorithm, you can do something like, can I stop a form from, I don't know, maybe submission? You can even find similar words. You can find a word that's similar to submission, but doesn't include these characters. Maybe a form can be expressed in, I don't know, like a report or something. I don't know. This algorithm does a really good job in finding similar words. So not according to the characters, but according to their semantic value, to their meaning, which makes this algorithm even more advanced, which means I can, in the fuzzy search, I can search like submit, submission, find submission. It will work because it finds similar characters. So one algorithm works based on the characters, but the vector works in a semantic meaning search. If I'm searching for programming, in the first one, I have to type something like program. So find these characters. But with vector, I don't need to include the word. I can search for coding, and because it uses some advanced searching, if it finds that coding is similar in meaning programming, it will give me the result. So you can express your question in different ways. So if I type like and you can test this using these two algorithms, like add some title that says title introduction to programming. And let me search through the first algorithm. Search.js, I don't know, beginner in coding. So if results length equals 0, console log, no results found. So I believe in this case, we didn't find a result because there are no strings found in any of the titles. There's no beginner, begin, coding. So the fuzzy search fails, but with this advanced algorithm, so begin in coding, there's no title that contain anything related to, like any string related to begin or coding. But we do have a string that has a similar meaning. Introduction to programming is closer to beginning coding. And you can see that from all the results that are scored by default, this vector algorithm scores everything. The only one that's kind of like gives us a high score is this one. So 63% is really good. So if I now filter and say, just give me everything above like 51%, I get like a result, which is really cool because you can search by meaning and not by keywords. So it's closer to this ChatGPT like search engines or even to Google. So this is really cool. And maybe even more powerful would be to combine these algorithms and have a search work using both algorithms on, let's say, different levels. So do a fuzzy search on like the tags and then do a vector search on like the content and combine both of them and give like the best of both worlds. So it's really up to you to experiment. The code is like relatively small, so you can study it and you can play around, and please come up with some nice experiments and share it with us. So that's it for today.